All right, hello again. So let's look at this trigonometric equation that involves sine function and a tangent function, and we have to manipulate that. All right, let's go through that. Let's solve this. The first thing we have to do, we have to make sure that we don't do anything illegal in terms of our algebraic operation. So here, sine of x times tan of 2x, we're going to bring the sine x to the left side and set that equal to 0. Here's a common mistake. Do not cancel the sine x. So don't do this. No, never. You cannot get rid of one of the factors like that. That's illegal. Okay, so we have to go through it this way. That's how we have to do this. All right, when we go to do this, we have to factor, take the GCF out, and that is sine of x. We'll get tan of 2x minus 1, set that equal to 0. And now we basically have two sets of equations, zero product rule. We have to go and solve each one. The first one, set sine of x equal to 0. And then the next one is you set tan of 2x minus 1 equal to 0. For first equation, sine of x equal to 0, that's just simple. X will be either 0 or pi. Remember the sine function again. Quick sketch. Where are the x-intercepts of the function? It is right here and there, so that's 0, pi. And I do have to actually, why don't we include that, because it says equal sign here. Because it says equal right here, that means that 2 pi is included. So the next one is actually 2 pi as well. So there are three x-intercepts, 3 solutions for sine of x. Great. Let's look at tan of 2x minus 1 equation. Okay, tan of 2x minus 1. So now we're going to look at this one. Now remember, we can easily say, you can replace the 2x with just theta and say, okay, what is tan of theta equal to 1? What is theta? Well, now you can think of the original function and you can go through it that way if you want to. And that's just, we can go through it, say that's 45 degrees or pi over 4. So we can set this up as tan of 2x equals to 1. And now we can say, okay, what angle will give us, where the tangent of that angle will give us 1, and that's 45 degrees, which is pi over 4. But we want x, not 2x, so x must be pi over 8. Great. The next one is the tangent also. So the next angle for the tangent of 2x equal to 1 is in quadrant 3. So that means we have to add another pi to the pi over 4, which is going to be 5 pi over 4, and that's in quadrant 3, and x now is 5 pi over 8. That is the second angle. We are not done yet. We still have to continue because we are looking at the entire range or domain between 0 and 2 pi, the interval that we want. So, but tan of 2, let's go back, tan of 2x function, this has a period of pi over 2 because tan of theta function has a period of pi. So we need to go ahead and include all the values up to 2 pi. And to do that, we know that these two solutions right here, these two solutions, they take care up to pi. But we want to go another pi because the total, the final value that we want to deal with is 2 pi right here. So what we can do, we can just get in every single one of these guys. So x equal to pi over 8. We get that and we say pi over 8, and we have to add pi to it so that we can complete the cycle and get to the end of the interval that is asking us to do. And in this case, we will end up getting, this is 9 pi over 8. So that's the next solution. And here as well, the same thing, 5 pi over 8 plus pi, and in this case we will get another 8 pi over 8, which would be 13 pi over 8. So we have now 4 solutions for the second equation, and we have 3 solutions for the first equation, and all of that together we have 7 solutions. Okay, very important. Make sure you go through this question again. You may need to pause it perhaps, go through each one of them again. By the way, there's another way of doing this question. The second part, the tan of 2x, you can also take the 2x equals to pi over 4. You add 2 pi to that and do the math on that one. You will end up getting the 9 pi over 8. And as well, you do the 5 pi over 4. You add 2 pi to that as well. You'll get 13 pi over 8 as well. That's another way of doing it. But I believe that this is the easiest way to do that, to kind of visualize that in terms of the total value for x that goes between 0 and 2 pi. All right, now remember, do not cancel. This is a crucial part that most students make a mistake. You cannot cancel the sine x from the both sides of the equation. That is an illegal algebraic operation when you're dealing with solving equations. You cannot cancel one of the factors, because if you do, that means you eliminate possible potential solutions.